Happy New Year, everyone. It's Jenny from Norman S. Wright. At the end of last year, we were talking about sound power and NC, noise criteria. I want to expand on that now and talk about calculating room sound pressure from catalog sound power using AHRI 885. So let's get started. A couple of videos back, I discussed sound power and NC. You'll see NC data in product catalogs for VAV boxes and grills, registers, and diffusers. What many people don't realize is that the NC numbers shown in manufacturers' catalogs are not measured numbers. They are calculated from the unit sound power using AHRI Standard 885. AHRI 885 gives sound attenuation values from common installations that you can subtract from the tested sound power to give you a room sound pressure, which you can then plot on an NC chart. I'll show you how this works. But let's talk about the standard itself first. AHRI Standard 885 is called Procedure for Estimating Occupied Space Sound Levels in the Application of Air Terminals and Air Outlets. It's full of tables for radiated and discharge sound attenuation, and the current version is AHRI 885 2008. The standard talks about a source path receiver concept. The source is the product, such as the VAV box we're going to talk about here later. The path is what's between you and the VAV box, and the receiver is what the occupant hears in the space. So let's move this out of the way and let's look at a VAV box over a ceiling. So let's draw this in real quick. You've got ductwork coming in, VAV box, ductwork going out, and your ceiling. So let's draw a person standing in this space. So the VAV box is our source. The person is the receiver. And between the source and the receiver is the path. In this case, it's the radiated sound path. And really the only thing in the radiated sound path is the ceiling. Now let's draw in a diffuser over here and look at the discharge sound path. So a lot more things can go into the discharge sound path. You've got the ductwork itself, and if it's lined, you've got the liner and the ductwork. You might have elbows or T's. There's end reflection where sound hits the end of the ductwork and bounces back, and then the air comes out of the diffuser and the path goes to the occupant. So AHRI 885 is full of tables that covers all the common installation components. So let's look at an example now. Let's move this over and start with radiated sound. I'm going to pull up the ceiling/space effect table. This table combines the ceiling tile types with a typical size space effect into one table that gives you the standard ceiling tile attenuation by octave bands for different ceiling types. So let's move this over and let's do an example. So let's say we have a product that has radiated sound power of 72, 66, 59, 54, 48, and 45 in the 2nd through 7th band. And now let's say it has a standard 20 pound per cubic foot, 0.63 inch ceiling tile. So we can go up to our table here and pull that row out. And that row is 16, 18, 20, 26, 31, and 36. So let's put the ceiling tile type over here. And if you subtract that, you get 56, 48, 39, 28, 17, and 9. But there's one more thing we have to account for, and it's called the environmental effect. The environmental effect is just a correction factor because we use the reference sound source in a reverb room when we do our testing, but it's calibrated in an anechoic chamber. So when you subtract that, you get 54, 47, 39, 28, 17, and 9 is your sound pressure levels by octave band in this space that has this ceiling tile with this specific product above the ceiling. Now if I bring in an NC chart, we can plot this on the NC chart. And when we plot this in here, you'll see we get approximately NC37. So this product would sound like an NC37 in this space. Now let's scoot this over and let's look at the discharge sound. There's a lot more factors that go into the attenuation of discharge sound. But again, AHRI 885 has tables to account for it. So let's just use the same sound power levels we had before. And now let's subtract the environmental effect. Let's put in some duct lining. Let's say it's 5 foot of 1-inch fiberglass duct lining. I got all these numbers from the tables in the standard, but in the interest of time, I'm not going to pull all these tables up for you. Next, let's say that we have, so this is the attenuation for 8-inch flex duct before the diffuser. And then there is a space effect, because if you discharge into a space of a certain size or you're a certain distance from the user, the discharge sound will sound different. So in this case, this is a 2,500 cubic foot room and the occupant is 5 feet from the sound source. And then there's N reflection. There's also an N reflection correction for airflows over 300 CFM. So let's say this is a 400 CFM box and this would be the correction for it. Now if we do all the math here, we come up with 45, 37, 28, 3, minus 6, and 6. Let's move that over now and bring our NC chart back and plot those on our NC chart. So you've got the first few here, and then the last ones are down here below the line. When you draw this in, you'll see that we get approximately NC26. Okay, let's bring the radiated sound back on screen. And let me see if I can make this discharge size smaller so I can get them both to be about the same size. So AHRI 885 has a lot of tables for these and other attenuation factors, so you can get really specific about your application. Now you don't need to for every project, but there are some times when it's important. If we look back at the ceiling attenuation numbers, you can see that ceilings attenuate a lot of sound. If you have a project that does not have a ceiling, then the catalog sound numbers will not be accurate for your application. You'll want to calculate the NC for your application without the ceiling attenuation numbers to get the most accurate NC. Another example over on the discharge side is the line ductwork and the flex duct at the diffuser. They both attenuate a lot of sound as well. So if you have a project with unlined ductwork or no flex duct, you're not going to get the same NC as the catalog data, and you'll want to run that selection with your specific application. Now, most selection software will allow you to change your attenuation factors. You just need to remember that if your application doesn't match the AHRI recommendations for catalog data, then you need to adjust them to make sure you get an accurate representation of what it'll sound like in your space. So that's an overview of calculating NC using AHRI 885. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.